Welcome back to the Deep Dive. Today, we are opening a really sensitive file. It's a window into the kind of instantaneous, life-critical safety communications that, govern global commercial flight. We're not just looking at some routine maintenance alert. We're diving deep into an official Airbus document, and it concerns one of the most successful aircraft families in the world, the A320.
That's right. And the source material we're looking at, it's a flight operations transmission, an FOT.
It's an internal memo, basically.
Exactly, but one that goes out, immediately across the globe to every single A320 operator. And the classification on this thing is really the key.
What's that?
It's classified as relating to airworthiness or safety.
So the highest priority.
The highest. This document, it details a mandatory immediate safety retrofit. It involves a core piece of the aircraft's brain, flight control computers, specifically something called ELACB.
And this is across the A319, A320, and A321 fleets.
The whole family.
Okay, so our mission today is to follow that chain of events. We need to understand the precise and, frankly, kind of astonishing flaw that triggered this mandate. And then, and this is the critical part, we have to dissect the really profound operational changes it forced on pilots.
Yeah, changes so radical that crews were actually, for a time, instructed to actively disregard their own emergency procedures manual.
Wow. Okay, so let's start at the beginning. What was the trigger?
Well, it all started with a recent incident on an Airbus A320. The report calls it an uncommanded and limited pitch-down event.
An uncommanded pitch down. I mean, that sounds absolutely terrifying, even if they say it was limited.
It is. Pitch control is, arguably the most fundamental aspect of flight.
Right.
And what was so concerning here was the subtlety of it. The autopilot, it actually stayed on, it remained engaged, the altitude loss was very brief.
It was enough.
It was enough to trigger a massive fleet-wide alarm, because any uncommanded pitch down is a huge red flag for airworthiness. When the computers controlling the flight surfaces do something they weren't explicitly told to do, the potential consequences are disastrous.
Okay, so let's get to the source of the problem. Often you expect these things to be mechanical. A failed actuator, maybe a hydraulic leak, something physical.
Right, something you can hold in your hand.
Exactly. But the investigation here, they didn't find a piece of metal that broke. They found a vulnerability deep inside a logic board. So what did they find was the precise culprit?
The issue was isolated to a very specific iteration of hardware and software. It was the ELACB computer unit when it was fitted with software standard L104. That was the problem child.
And the root cause. This is what makes this story so unique. It wasn't really a flaw in the programming logic itself, was it? It was about exposure to environmental factors.
That is the truly chilling detail. This vulnerability only emerged in specific aircraft configurations, and critically, the document says, in case of exposure to atmospheric radiation.
Atmospheric radiation. You're talking about cosmic rays.
We are talking about cosmic rays.
Wait, hold on. So you mean literally particles from deep space are hitting a microchip at 35,000 feet and causing an unexpected input that moves the elevator on the plane? That sounds like science fiction.
It sounds extreme, but it's a very real phenomenon in avionics engineering. They call them single event upsets.
Okay.
See, at cruise altitude, you have less atmosphere protecting you. These high-energy subatomic particles can and do penetrate the aircraft's structure. And if one of those particles strikes a sensitive electronic circuit in that specific ELACB,
it can flip a bit.
It can flip a bit in the memory, yeah. It essentially corrupts a command signal.
So in this one software version, L104, that corrupted signal led directly to an uncommanded pitch change. It's an almost invisible point of failure.
From an error that could have originated billions of miles away. And the stakes, as the document defines them, they confirm this was no minor glitch.
What does it say?
It spells out the risk, saying this vulnerability could lead in the worst-case scenario to an uncommanded elevator movement that may result in exceeding the aircraft's certified structural capability.
Exceeding structural capability. That's the polite engineering way of saying the plane could break apart in midair.
Precisely. And that diagnosis immediately elevated this from a technical patch to an urgent mandatory safety recall.
It required immediate fleet-wide action.
Absolutely. Which brings us to the Alert Operational Transmission, the AOT.
AOT A27N02225.
That's the one. And that AOT mandated the immediate removal of that vulnerable ELCB L104 standard. They had to retrofit it back to the previous stable standard, L103 plus X.
So it wasn't an upgrade, it was a rollback.
A targeted removal, exactly. They had to get that one specific susceptible standard out of the fleet.
So they fixed the hardware, they solved the cosmic ray vulnerability. But this is where the domino effect really starts to hit the cockpit procedures, right? Because retrofitting from L104 back to L103 Plus wasn't just a simple plug-and-play fix.
Not at all.
It fundamentally changes the rules of the game, the flight control laws that govern how the plane flies. This is where it gets really, really complex for the pilots.
This is the absolute crux of the pilot challenge. You have to remember, Airbus uses fly-by-wire technology.
So the stick isn't directly connected to the flaps and rudder.
Exactly. The control stick sends a command to the computers, like the ELAC, which then moves the surfaces according to a predefined set of rules. Those are the control laws.
Okay, so let's simplify those laws a bit. As I understand it, normal law, or NOR law, that's the most protected state. What does that protection actually look like for a pilot?
Normal law is the aircraft's safety net. It maintains what we call full flight envelope protection. So if you pull back too hard on the stick, the computer won't let you stall the plane.
It'll just stop you.
It'll stop you. If you bank too steeply, it limits the angle. If you go too fast, it automatically pitches the nose up. The pilot is essentially commanding a flight path, and the computer manages all the physics to keep the aircraft safe.
But this fix, this rollback to L103 plus phase, it means certain failure scenarios no longer keep the aircraft inside that safety net.
Exactly right. For some specific aircraft variants, the A319 CEO with sharklets and the A319 and A320 CEO with the old wingtip fences, the consequences of certain failures were radically altered by this software change.
Okay, so which failures are we talking about here?
The big ones are a yaw damper failure or a dual FAC failure.
FAC being the flight augmentation computers.
Right, they help stabilize the plane. Now, under the old L104 system, if you had those failures, the aircraft stayed in normal law. The computer would basically say, okay, we've lost some capability, but I can still protect you.
But now, under L103 plus HRSA, what happens?
They drop immediately, straight to alternate law, ALT law. And this is a massive procedural shift. Alternate law means you're now in pitch alternate law with reduced protections and rolled direct law.
Let's unpack that jargon, because that's the key. What does reduced protection actually mean in the cockpit? Is the computer still stopping you from stalling?
No. And that is the critical difference. In alternate law, those sophisticated protections are gone. The angle of attack protection, the anti-stall system, it's no longer guaranteed.
So the pilot is now responsible.
The pilot is now fully responsible for managing the flight envelope. You're back to relying on traditional warnings instead of automated intervention. The safety barrier is, for all intents and purposes, removed.
Wow. So a failure that used to be manageable, that kept you in a NOR law, now suddenly throws you into a situation where you're flying the plane with far fewer safety buffers, all while trying to handle an emergency.
Exactly. And the reversion doesn't stop there. The document makes it clear. When you put the landing gear down and turn the autopilot off, the flight controls revert entirely to direct law.
And direct law is. That's basically flying a conventional aircraft, right?
Right.
There's no computer helping you at all.
Correct. In direct law, the relationship between your stick movement and the control surface movement is completely linear. It's unaugmented. The pilot is directly responsible for every single aspect of stability and control.
Making that shift during an emergency approach, that's a huge increase in workload and risk.
Enormous. And it's not just those specific variants that are affected. The document also points out a more generalized loss of protection.
Oh.
That's right. The pitch attitude limitation, which stops the nose from pitching up or down too steeply, is explicitly not available in alternate law for all the affected aircraft with L103 plus SSE. That includes the NEO and CEO variants.
So any failure that leads to alternate law means those pitch protections are just gone.
Gone. And there's a third, smaller change too. The bank angle protection behaves differently during a high-speed protection event. All of these little nuances, they completely change the nature of flying the aircraft when something goes wrong. Which brings us to the really urgent part of this FOT, the operational transition and this 15-day deadline.
Right. So we've got a hardware fix being rolled out fleet-wide. We know the laws of flight have functionally changed for the pilots, so how fast does the paperwork have to catch up?
Very, very fast. Airbus planned to publish the emergency FTIM, that's the Flight Operations Manual revision, during week 49. From the moment operators get that revision, they have a strict 15 calendar days to get it implemented.
15 days to update thousands of manuals, physical and digital, and train thousands of pilots globally on a fundamental change to their emergency response.
It's an intense operational pressure. It is the ultimate coordination challenge.
But what about that gap? I mean, the time between the plane getting the L103 Plus fix and the pilots actually having the correct signed-off procedures in front of them.
A very dangerous gap, and Airbus had to mitigate that risk.
How do you do that? What stops a pilot from just relying on the now obsolete procedure?
Well, they rely on two things. First, they confirm that the ECAM, the central warning display in the cockpit, is consistent with the new ELMNIAC logic, so the computer's alert will still be correct.
But the procedure the pilot pulls up in their manual to deal with that alert will be wrong. It'll be based on the old normal law reversion.
Precisely. Which is why, until that new documentation is formally on board, the FOT mandates that specific information from this bulletin, the paragraphs explaining the shift from normal to alternate law, must be delivered to flight crews before every single flight.
A mandatory brief.
A mandatory active mitigation briefing. Can you imagine being a training captain trying to roll this out? A fix this complex that changes core safety philosophy in just 2 weeks while making sure every single crew gets this briefing.
The pressure must be immense.
And this leads us to the absolute core insight of the whole document, the most critical warning. For those specific planes affected by the NOR to LT law shift, the crews are told they must actively not refer to the FCOM Pro ABN Auto FLT section for 2 specific failures.
Which failures?
The Auto FLT FC1 plus 2 fault and the Auto FLT yaw damper.
That is just.
Yeah.
It's profound. Pilots are trained, they're drilled, their entire career is based on following those emergency procedures without deviation.
To the letter.
For a company like Airbus to tell them to ignore a section of the manual for life-critical failures, I mean, even temporarily, that just highlights the sheer severity of this change.
It does. It means that if those specific failures happen during that 15-day gap, the pilot's muscle memory, the training to reach for that checklist, is now incorrect. It's potentially dangerous.
They have to rely solely on the briefing they got before the flight.
On the briefing and their own understanding of these new L103 plus control laws, which is why that mandatory awareness training was so essential.
And they even added one more layer of precaution, didn't they? About dispatching the planes.
They did. They recommended avoiding dispatch for their same variants under a specific maintenance deferral, ML 226002AC2, until the onboard documentation was updated. They were basically telling operators, if you have any ambiguity about your system status during this transition,
Keep the plane on the ground.
keep it on the ground. They were minimizing every possible risk while the procedures caught up to the new reality of how the aircraft flies.
So let's bring this all back together. We've tracked an incident, traced the root cause to a software vulnerability in the ELAC BL104, a vulnerability likely triggered by, of all things, cosmic rays.
Which then mandated a rapid, fleet-wide technical retrofit.
And that retrofit had this huge domino effect. It instantaneously changed the fundamental logic of flight for a big part of the A320 family. Certain failures that used to be safe, keeping pilots in normal law, now throw them immediately into the much more demanding world of alternate law.
A world stripped of key flight envelope protections. And the response was this incredibly tight 15-day clock, forcing operators to update their manuals and, in that interim period, demanding that flight crews literally ignore parts of their established emergency checklists.
You've really seen the sheer speed and the level of detail required to manage this kind of life-critical information across the entire global aerospace network.
What's so fascinating here is just realizing that the physics and the procedures of flying an aircraft, they aren't static. They're not set in stone. A tiny fall caused by a random environmental factor can force an instant shift in procedure. And the entire human-machine ecosystem has to adapt, instantly.
And it really leaves us with this provocative thought to consider, doesn't it? If correcting one specific software vulnerability requires pilots to actively ignore their established, drilled-in emergency procedure manuals until a hard deadline passes, what does that tell you about the inherent complexity, maybe even the fragility, of these critical systems that rely on such a perfect balance between human training, automated protection, and constantly evolving software?
It's something to mull over the next time you hear that reassuring chime as you settle into your seat. Thank you for diving deep with us.